In April of 1963, a United States Navy submarine prepared for a routine deep dive in the Atlantic Ocean. The submarine was USS Thresher. On board were 129 men. The mission was a standard test. Nothing about it suggested danger. The USS Thresher was one of the most advanced submarines of its time. A nuclear-powered attack submarine designed for deep diving, speed, and stealth. It represented the cutting edge of Cold War naval technology. After undergoing maintenance and upgrades, the Thresher was ready for sea trials. These tests would push the submarine to its limits, including a deep dive to evaluate its systems under pressure. On April 10th, the submarine left port, accompanied by a rescue and support ship. The ocean conditions were calm. Everything appeared normal. The next morning, the Thresher began its descent. As the submarine moved deeper beneath the surface, pressure increased rapidly. Every component of the vessel was tested by the crushing force of the ocean. Inside, the crew monitored systems carefully. Depth readings, hull integrity, mechanical performance. Communication with the surface ship remained steady. At first, nothing seemed out of the ordinary. But then, something went wrong. At a great depth, a pipe in the engine room began to leak. High-pressure seawater sprayed into the compartment. The leak may have been caused by a failure in a brazed pipe joint. Under extreme pressure, even a small weakness could become catastrophic. Water entering the submarine created immediate danger. Electrical systems were affected. Equipment began to fail. The crew attempted to respond. Procedures were initiated. Valves were closed. Pumps were activated. But the situation escalated quickly. Seawater continued to flood into the submarine. Short circuits disrupted critical systems. The reactor automatically shut down as a safety measure. This meant the submarine lost its main source of propulsion. Without power, the Thresher could no longer control its depth effectively. It began to sink. Inside the submarine, the crew attempted an emergency procedure. They tried to blow the ballast tanks. This process forces compressed air into the tanks to expel water, making the submarine more buoyant and allowing it to rise. But at great depth, this system faced a critical problem. Moisture in the compressed air lines froze as it expanded. Ice formed inside the valves. The flow of air was restricted. The ballast tanks could not be fully cleared. The submarine could not regain buoyancy. It continued descending. Communication with the surface ship became fragmented. Short, broken transmissions were received. Then one final message. After that, silence. Moments later, underwater listening systems detected a series of sharp sounds. The signals were consistent with a sudden structural collapse. At extreme depth, the pressure of the ocean becomes overwhelming. If a submarine descends beyond its design limits, the hull can fail instantly. When that happens, the collapse occurs in a fraction of a second. There is no time to react, no time to escape. The USS Thresher was lost with all 129 crew members on board. The search began immediately. Ships and aircraft were deployed across the area, but the ocean gave no immediate answers. Weeks later, deep-sea exploration equipment located the wreck. It was scattered across the ocean floor. The debris field confirmed what had happened. The submarine had descended beyond its limits and suffered catastrophic implosion. The loss of the Thresher shocked the United States Navy. It revealed critical weaknesses in submarine design, construction, and testing procedures. An investigation followed. Engineers studied every possible cause: the failure of a pipe joint, the vulnerability of electrical systems, the limitations of emergency ballast systems at great depth. From this disaster came major changes. The Navy introduced a program called SubSafe. It focused on improving the reliability of critical systems, stronger materials, better testing, more rigorous inspections. Every component related to seawater systems and hull integrity was reevaluated. The goal was simple: ensure that a failure like Thresher would never happen again. The program became one of the most important safety initiatives in naval history, and it worked. Since its introduction, no SubSafe certified submarine has been lost due to structural failure, but the cost of that lesson was 129 lives. The USS Thresher remains on the ocean floor today, deep beneath the Atlantic, a reminder of how quickly technology can fail under extreme conditions, and how unforgiving the deep ocean can be. The crew had no warning, no chance to escape, only moments between control and catastrophe. Some missions begin as routine until something goes wrong, and beneath the ocean, there is no margin for error. This was the last expedition,